Okay, for homework 913, I'm going to have you copy a few of these and the 3 words to show me that you listen. So again, I want you to be able to get these and graph them. So this first one here, I could see that I'm adding by 3. As soon as I see that, it's going to be arithmetic, going to be a straight line. Already have the 0 term there. If I wanted to write recursive, I could just write it right away. F of x equals f of x minus 1 plus that 3 number right there. If I wanted to use it in the table, take that 7, 7 plus 3, 10, 10 plus 3, 13, 13 plus 3, 16, 16 plus 3, 19. But can't do that for the 51st. Going to have to come up with the formula. If they're asking you to prove it that the recursive function works, here we go. Let's find that 6th term by plugging in into that formula a 6 into x. So here I go. So that function, the recursive, plug in 6 right here. Plug in 6 right here. That gives me the function at the 6th term comes from the value of the 5th one, the 1 before it, and just add it to 3. Take that value of the 5th term, which is 16, and replace that right there. So when I write that, the 6th term comes from me taking that 16 right there and adding 3. That gives me the 6th term is 19. If I wanted to jump ahead to the 51st, I need to use both forms of explicit. So the first one, using that number in front of x, plus the y-intercept term if it's listed, the 0 term already listed. If you don't need to backtrack, don't backtrack. Or I could use the second one, that 3, open up the parenthesis, x minus 1, but shift over and not use that 0, 1 term, use the 4 right there, so that 4. And I could take that 51 and plug it in to either of my x's to get that same answer. If I use that top one, plug in 51 right here, 3 times 51 plus 1. That gives me 3 times 51. Use my calculator because I don't trust my arithmetic. Gives me 153. So that tells me that at the 51st term, 154. Make sure you put that number in there. If I use the second one, should still give me that answer. I can circle that. Let's go. All right, the second one. Plugging in 51 into that one where you're subtracting 1 away from it first. And then adding 4 instead. The other one had you use the 0 term and use just 3 times x. This one a little different. So this one I'm plugging in 3. Subtract 1 gives me 50. And then you can see right there, that gives me the 51st term is 150 plus 4 gives me 154, just like that previous one did before that. And I need you to graph these. These all give you coordinates. The first coordinate, some people like to plot 0, 1, 1, 4, 2, 7. Know that these arithmetic straight line always. So 0, 1, 0, 1 on the y-axis. Over 1, up 4. Over 2, up 7. Knowing that if I draw a line through these points, it will go through that y-intercept at that 1 and will follow that slope. Know that this line goes forever. I could either go over 1, up 4, over 1, over 1, up 3, over 1, up 3, or I could stair step the opposite way. Left 1, down 1, left 3, down 1, left 3, down 1, left 3. All those points are on the line. If I was to go backwards to the -1 term for x, or the -2 term for x, again taking that 1, 1 minus 3 would give me negative 2. Negative 2 minus 3 will give me negative 5. Those points should be on there too. Negative 1 for x, negative 2 for y, a little bit more precise. Negative 2 for x, negative 5 for y. All those points are on that line. First word is lion. Lion. All right, this next one. This one is geometric. Noticing that I'm timesing by 2's right here. Timesing by 2's. Let's erase that first, let you catch up. But again, timesing that by 2. Timesing by 2. Let's do that in red. So I can fill out that table. 8 times 2, 16 times 2, 32 times 2, 64. I'm going to jump ahead though to find this 10th one right here. Know that recursive times 2. So find the previous term before it and just times it by 2 to find the next one. That is recursive. Know that this one is geometric, going to be a curved line if I do this properly. The explicits, which I'm going to jump ahead to on this one, I could either use the 0 term, that one, right here, this 0 term, this is the first term. I could either use that 1 times my common ratio to the x power, or I could use the first term instead, which is 2 times that same 2 to the x minus 1 power. My pen lets me write. So if I'm plugging in this 10 right here, that 10 is being replaced into either of these x's. Notice that this formula way different than something just being times by x. Way different. This problem is a number raised to an exponent spot. So if I plug that in, try to find the 10th term. Let's do that. I got 1 times 2 to the 10th. Gives me the 10th term right there. 1 times 2 raised to the 10th power. Use my calculator if I can find it. Gives me 1024. Of course, that times 1 gives me 1024. I could also use the other formula to find that same answer. Plug in 10, 2 times 2, but this one a little different. The 10 minus 1 power, which gives me 2. Don't times those 2. 2 to the 9th. Do 2 to the 9th first. Gives me 512. And then if I finally times that 2 times there, that gives me the same answer as the one above it, 1024. I do want you to graph these. So graphing these, 0, 1 right here. Over 1, up 2. Over 2, up 4. You can see the increase. Over 3, up 8. You can see that big increase. Over 4, up 16 will be here. But then all the small numbers going to the negative 1 for x, and negative 2 for x, and negative 3 for x. Remember, timesing up by a half. Dividing by 2 is the same as multiplying by the reciprocal. So if I did that, 1 times a half will give me that term right there, which is 1 half. 1 half times another half gives me 1/4. 1/4 times another half gives me 1/8. And if you look at those values, this is 0.5, 0.25, 0.125. Those are why the values are getting smaller over here. Negative 1 for x, only up a half for y. Negative 2 for x, only up a quarter. Negative 3 for x, even less up than that. And again, none of those points will ever touch 0. They'll just get closer. So that is your geometric. The second word is black. Black. All right, we're going to skip ahead to this one right here. Number 4. and the last word. All right, for this is geometric timesing by a half because I'm dividing by 2. So if I take 5 halves times 1/2, remember, straight across gives me 5/4 times another half gives me 5/8. You got to know that pattern going downwards like that. So again, 10 times a half, 10/2, 5. 5 times a half, 5 times 1/2, 5 halves. 5 halves times 1/2, 5/4 times 1/2, 5/8 times 1/2, 5/16. This one right here, I'm not sure. I'll have to plug it in. So recursive, always a recursive formula to these. But again, I just used it. It's nothing more than to find any term, know the one before it, and know what you're timesing. Notice there's no division in there. Even though I was dividing going down, we write it as timesing by a half. If I was to graph it, 0, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over 1, up 5. 1, 2, 3, 4, 5. Over 2, up 2.5. So these, you might want to start writing these as actual decimal numbers. So a little bit easier to graph than fractions. 5/4 is 1.25. 5/8 is 0.625. 5/16 is 0.3125. Those are the small values. So here we go. 0, 10. Over 1, up 5. Over 2, up 2.5 boxes. Over 3, up 1.25 boxes. Over 4, up just over a half, 0.65. Over 5, a little bit smaller than that. Over 6, a little bit smaller. So you can see this one is curving downwards like that. And you can see where these small values come from these fractions. If I'm jumping ahead to the 8th, use both forms of explicit. Use either the 0 term right there or the first term. 0 term, use that 10 times the ratio number 1/2 raised to the x power. Or use the first term 5 times that 1/2 raised to the x minus 1 power. Take that value 8 and plug it into either one for x. Here I go. First one. Let's do this in black. Find 8 comes from 10 times 1/2 to the 8th power. That's a half times a half times a half, all the way 8 of those. So that's going to be 1/2 to the 8th power. That gives me 10 times 1/256. By rule, put that over 1 times straight across, and that gives me the 8th term is 10/256. The beauty of these calculators, they will reduce that fraction for you. Reduces down to 5/128, which is about 0.039. If I do that for the other one, it should be the same. Plug in 8, 5 times 1/2 to the 8 minus 1 power gives me 5 to the 1/2 raised to the 7th. So again, that's going to be 1/2 times 1/2 times 1/2, or 5 times 1/2 to the 7th. Gives me 128. Put that over 1 straight across. Gives me the exact same answer, 5/128. All right, last word is finals. Finals. Good luck. See ya tomorrow.